Hello friends, welcome to Zydex. Today we are here to talk about Zydex patented 100% reactive organosilane chemical. Zydex penetrative nanotechnology is for permanently changing the polarity of surface hydroxyl ions in order to change them from hydrophilic to hydrophobic. We are here today to see the visible effect of this innovative treatment on various types of building materials. We are all aware that most of the damage takes place due to water ingress in building materials. So let us see what is the effect of Zydex nanotechnology on them. So let us find out what are the different kinds of building materials in these kits. In this first kit, here we have a dropper. You see this is a concrete block, a miniature concrete block. Here we have a piece of plaster, a small piece of plaster. We also have a small piece of brick here. This is a miniature brick. Apart from this, we also have various types of soils which we have treated with our technology. This is a yellow soil. Here is a sample of black soil. And here we have ordinary sand. Apart from this, another type of popular building material which is finding its place in the construction industry are the fly ash bricks, also known as AAC blocks. Here we have a miniature sample of AAC block. These samples are half treated with organosilane chemical and half untreated. As it is a penetrative and reactive technology, you would see visually it's very difficult to find out which area has been treated with the chemical and which is not. We will carry out a drop test. Here we have some ordinary drinking water with us, and we will put a small drop on these building materials in order to find out which side of these materials has been treated. As we put this drop on this brick surface, you would see this is what you would normally expect, that the water gets absorbed inside the brick. While we do it on the other side, you would see that the water droplet is not only not penetrating inside, but it is running off from the surface. Now let us do the same thing with the plaster block. We put a few drops on one side of the plaster. Now let us try to do this on the other side. As you see, there is no water absorption on this side. Now let us again do the same thing with the fly ash brick. You see the water getting absorbed. Now we shall do it on the opposite side. You can visualize the difference between a treated and an untreated surface. Here we have a small concrete block. Let us presume that it's raining and the block is going to completely get drenched with water. We'll try to dip it inside the water and let us see what happens. Here you would see that the untreated side is getting wet, whereas the treated side remains dry. That is the difference between a treated and untreated surface. Now we will take out samples of these treated soil. Here we have a small quantity of yellow soil with us. We have some quantity of black cotton soil. this soil is supposed to be highly water absorbing. And here we have a sample of treated sand. Let's make a small indentation on the surface so that it can contain and absorb water. Now let us see what is the effect of on these soils when it comes in contact with water. As you can see on this yellow soil, you have kept a small drop of water on top of this. Here is the black cotton soil. And here we have ordinary sand. As you would observe, there is absolutely no absorption of water by these soils. After the soil test, here we have a real life-size brick with us. You would see that there's a grooving in the middle of the brick. One side of the brick we have treated with our organosilane nanotechnology, and another side is left untreated. Now we would do a time test on this sample and would see how capillary rise of water affects on this particular brick. We would make a pool of water in front of the brick and allow it some time and observe what are the changes that are taking place. So now we go back to the brick which we had submerged underwater. As you recollect, we have one side of the brick which is treated with organosilane, and there is the other side which is untreated. You can make the visual difference. There is a capillary rise which has taken place inside the brick. On the treated surface, we see no capillary rise taking place. This is what exactly happens in our houses during monsoon or for some other reasons. When the water table rises up, we see a rising dampness on the walls. A treated surface ensures that the water in its liquid form is not able to rise on a treated building material. As you have seen the effect of organosilane treatment on various building materials, what comes to our mind next is where should we use it? So let us understand where we should use this nanotechnology in order to protect our structures. First, let's talk about above ground structures. Most of the area which sees exposure to water is the vertical walls, and we have to protect our vertical walls from water seepage and water dampness ingressing inside. We have our terrace, which is another area which observes not only direct exposure to water, but it also sees standing water during heavy rains. That is one area which can be treated with this chemical. We have inside the building, we have sunkens, we have the wet areas, which is the toilets and bathrooms. We have our verticals outside the structure, some podiums. Those are the areas which directly sees water. Below ground, if we go, there are various areas which experiences water. At the foundation soil, from the blind side, we would, as we have seen, that there is capillary rise of water takes place through the soil. So the foundation soil can be treated with this technology. The footings, whether it is isolation footing or pile type structure or a raft foundation, it can be treated from all the external sides, which is going to see direct experience of water. We have the retaining walls, we have the basement sides, where even waterproof soil can be used for backfilling. This nanotechnology can be used to protect a building, to make it completely water insulate from 360 degrees. After doing this treatment, we can always do the conventional application of paints or waterproofing technologies, membrane technologies for further protection. But this ensures that you have a substrate which is completely non-water absorbing, and by stopping water ingress into the structure, we are tremendously deaccelerating the aging of the concrete structure. Thank you so much. Thank you for being with us.